Hi. Today we can see queue interface and subclasses of queue interface and map interface and subclasses of map interface in the collection API. I created a different package CommVKRQ. I'll go to the first program. See, similar to the list and set interfaces, queue interface also from the java.util package. Whatever interface and classes inside a queue, all are from the java.util package. Queue is an interface. We cannot create object to the queue directly, but we can create object to the subclasses of queue and get use that objects. First subclass of queue is PriorityQueue. I just created object to the queue. Queue is taking a type of string type. This is a generic. We are allowing only string elements into the queue. So this is from the Java 1 JDK 1.5 onwards. We have this feature, generic feature. If we want to restrict any collection API to allow only specific data type elements, we can allow by using the generics. Here it will allow only strings. Earlier, if you won't use a generic type, you can add any type of elements. You can add string, we can add number, we can add any object. So I created a queue object by using generic type of string type. So I added the elements. Queue.add of ABC, queue.add of XYZ and PQR. Queue also interface extents of collection interface. Whatever common methods are there inside the distance set, we have the same methods in the queue also. Few methods. Here, add method is same for all things. Now, how to add the elements to the queue? I can add the elements to the queue by calling the add method. No, I am just printing the elements. System.out.println of queue. So we are just printing the priority queue elements, ABC, XYZ, and PQR. If you want to remove the element, if you call simply queue.remove method, it will remove the first element of queue. Queue is a data structure. The collection API interface and subclasses of queue interfaces are maintaining one order. That order is first in, first out. If you add any elements, that elements are adding at the end of the queue. If you remove any element, the element is removing from the starting of the queue. Adding elements at the end, removing elements from at the starting. That is the flow of the queue. That is the queue based functionality. If you have a requirement of processing the elements first in, first out, whatever is coming first, that element we have to remove first. So we can use queue interface classes. Now I created an object to the queue. I'm just adding the elements. After adding the elements, I'm printing the queue. So I want to remove the element of first element of queue. So I call the queue.remove method. If you call the queue.remove method, it will remove the first element of the queue. That is a method for removing the element in the queue. We have different way of removing the element also. That's how we can see in this one in the same program. I'm just adding the one more element, 1, 2, 3. If you add the element, it will add at the end of the queue. So we'll get the queue is inside the queue. We'll get the last element is 1, 2, 3 because adding is to the last element. Because first in, first out. Whatever element is coming first, it will come out first. Now here I am just printing the queue again. Now here we removed the first element and we added the one more element at the end. So we'll get the output only 3 elements here. We have a poll method. If you want to remove the element and get the element also. If you want to get the element and remove the element. If you want to do both operations, getting and removing, We have poll method. Poll method is removing the first element and reading the first element. If you call system.out.println, it will return the string type. So we will get the output of first element of queue. Here, whenever you are printing this one, whatever elements are there, the first element it will poll. Now here I am again, after polling, I am just printing the elements. Here what we are doing is, if you want to find the element is present or not, we have a contains method. By using contains method, you can find the elements are present or not. Let's go and run this up to till now. We can see what is the output. Now, whenever we created a queue, A, B, C, X, Y, Z, P, Q, R, we got all elements. Now I removed the element, first element. After removing the first element, we remove the ABC. So we'll get the output of XYZ PQR. Then again I am adding the element Q dot add of 1 to 3. So we're adding a first element is 1 to 3. So we got the output like this. Whenever we print the Q second time. So if you call the poll method will poll the first element because Q is first in, first out. Whatever is entering is that is the first element. Removing element also first element. Now here, after polling, we are printing the queue. After polling the first element, we got the output as PQR XYZ. So if you want to find the element is present on there or not in the queue, you can find it using the contains method. If it is XYZ is contains, it will give true. If XYZ is not contains, it will give the false. So we got the output as true. We have one more method to get the element. Only if you want to get the element, you can call peek method. If you call the peek method, it will just give the element of a first element. So the first element is in the queue is PQR. We got the output is PQR here. Whenever we call this. Now here the important thing is we have to remember two methods. One is the peek method. One is the poll method. Peek method is just getting the element. It won't remove the element. Poll method, it is just getting the element and removing the element also. Now if an interviewer, they will ask what is the difference between peek and poll methods. You should be able to answer. Peek method of the queue to just get the element and we can print that element. Poll method of the queue to just get the elements and remove the element also. That is the use of peek and poll methods. Now if you want to read the elements of the queue, similar to the other collection classes and interfaces, we have iterator, queue.iterator. Just give the iterator reference. By using iterator reference, we have hash next method and next method. By using iterator, I am just iterating all the elements. We have only two elements. We got the elements PQR XYZ after reading the elements. Now in this program, what we have seen, we just created a queue and adding the elements. After adding the elements, removing the element. How to remove the element? If you want to only remove the element, call the remove method. It will remove the first element. If you want to remove and get the element, you can call the poll method. This is a poll method, whatever I selected. If you want to only get the element, we have peek method. If you want to check whether element is present or not, we have contains method. If you want to read all the elements of a queue, we have this one, iterator. Now here, that is about the queue. Now coming to the priority queue, what it will do. See, inside a queue interface, we have two classes. Subclass of queue is PriorityQueue and LinkedList. We have other classes also. We'll see in the next examples. But what is PriorityQueue? PriorityQueue is maintaining the order. Whatever elements you are adding, first out. whenever elements we are adding to the queue, the elements are processing into the queue in the form of first in, first out. It is following the first in, first out, and to create object using the priority queue. See, we cannot create object to the queue interface directly. We have to create the object using the subclass of the queue interface. So I am using the priority queue. If you use a priority queue, the order is adding the elements and removing the elements using the first in, first out. Adding the elements at the first, removing the element at the first. So it is following the first in, first out, but it is following another thing also. It is following adding and removing the adding the elements based on the priority. Reading the elements based on priority. See, we have numbers. For example, we have numbers from 1 to 1, 2, 3, something like that, up to 10. Now, what is highest priority? What is having highest value? If the 10 number is having, this is the highest value. So we have to get this first. If 2 is the number, this is highest, this is lowest priority than 1. So we have to get this one at the last. So here inside the queue, whatever less element is there, whenever we are getting the elements, those elements will get the highest priority. First 1 we can get, next 2 will get, next 3 will get, next 4 will get. Based on the priority, we'll get the elements. Queue is working based on the first in, first out mechanism. And if you create the queue object using PriorityQueue is having additional functionality of reading the elements based on the priority. So let's go to the next example and see how we are reading the elements based on the priority. This is one example of how to add the elements to the priority queue and remove the elements from the priority queue by using remove method and poll method. How to identify the element is present or not by using context method. How to read the element? You can call the peek method to read the element. If you want to read and delete the element, we have poll method. How to iterate the elements? We have iterator. So let's go to the next program. Yeah, coming to the next program. In program 2. Now, how many ways we can create object to the queue object? How many ways we can create object to the queue interface? We cannot create object to the queue interface directly, but we can create object to the queue interface by using the subclasses of queue. So we have priority queue, and we have linked list. Linked list also subclass of queue, and we have priority blocking queue. We have 3 interfaces. By using these 3 classes, we can create object to the queue interface. Now let's go and see. See, I just created object to the queue by using priority queue subclass. So I am just adding the elements 100, 150, 20, 30, 40. I added 5 elements. So whenever you want to read the element, I just call priority queue dot peek. Whenever you call peek method, it is just should read the first element. But since it is a priority queue working based on the first in, first out, and sometime it will work based on the priority. Whatever elements inside the queue, what is the least element? We have 20. We'll get the output as 20 here. We won't get the output as 100 here, because here in this condition, this priority queue working based on the priority. Priority means what is the least element, we'll get in the peek method. So I'm getting the 20 here when we call the peek. And then poll method. Poll method is just getting the first element and removing the first element. It will give the 20 again, and it will remove the 20 from the queue. So again I'm calling the peek method. Peek method will give the next least element. Next least element is 30. So I'll print all the elements of a priority queue. If you print all the elements of priority queue, we'll get the 30, 40, 100 and 150. Let's go and run this. Now first, peak method. Based on the priority, it get the elements. It is not getting the elements based on the first in, first out. Basically, whenever you call peak method, it should get the first element. But it is not getting the first element. It is getting the elements based on the priority. That is the beauty of the priority queue. So a poll method, it is just removing the 20 and getting the 20. Next element is 30. Peak method is getting the 30. So we got output as 30, 40, 100 and 50. That is about the priority queue. And here the priority queue is not maintaining any order. 100, 150, all these are not in order. Go to the linked list. Creating object to the linked list, adding the elements 10, 20, 15, 30, 40. So whenever we call the peak method, it will give the first element because this is a first in, first out, and it is a very less element. Inside all linked list queue, we have 5 objects. All 5 objects are least value is 10. So we'll get the 10 first. Whenever we call poll, 10 is getting and 10 is removing. And whenever we call peak, next element is 15. We'll get the next element is 15. Oh, sorry, it won't get the 15. It will get the 20 because next element is 20. By using linked list, if you create object to the queue, it is maintaining one order. Based on order only, we'll get the data. So this is maintaining order. All the elements coming from the first in, first out. Queue is following first in, first out here in case of linked list. Just remember this. Now first element peak method will give the first 10, and whenever we call poll, 10 is getting again and removing the 10 from the linked list. So whenever we call the peak, we'll get the 20. It is not getting based on the priority because it is not a priority queue, it is a linked list. So we'll get the in order. If you want to maintain the elements in the order of a queue, we can use the linked list. If you don't want to maintain any order, what we have to use in the queue? We can use in the priority queue class. Now let's go to the priority blocking queue. I just added elements 10, 20, 15, 30, 40. Whenever I call peak method, we'll get the output as 10. Whenever we call poll method, first it is 10 is getting and 10 is removed. And whenever we call the peak method, we'll get the same 15. Because it is priority blocking queue also based on the priority queue only. But this will give additional functionality of thread safeness. The methods inside the priority blocking queue are thread safe. Whatever methods are inside the priority queue, those are not thread safe. What is thread safe means? All the methods inside the priority blocking queue is synchronized. So multiple threads cannot access at the same time. Only one thread able to access the priority blocking queue methods. We can see all the difference between the priority queue, linked list, and priority blocking queue. Now here, we'll see priority queue again one more time. Priority queue 1 I have added. I just added the elements ABC, XYZ, PQR, RST 1, 2, 3. So whenever we call the peak method, here least priority is 1, 2, 3. In case of strings, it is also finding the priority based on the hash code of the string. Hash code of the 1, 2, 3 is least compared to hash code of the ABC. So we get the whenever we call peak method, we'll get the output of 1, 2, 3. Whenever we call the poll method, first it is removing the 1, 2, 3 and getting the 1, 2, 3. Peak method again. Next element is ABC. We will get the output of ABC. See here. Now this is a priority queue, linked list, and priority blocking queue. Now let's see what are the difference between priority queue, linked list, and priority blocking queue. In case of priority queue working based on first in first out or priority of the element. It will take anything. The elements are from the 1, 2, 3, 4, something like that. It is in some order, then it will follow the first in first out. If the elements are in something a different order, in that case it will follow the priority of the element. And coming to the linked list, creating queue object using a linked list. It is working based on the first in first out, and it is maintaining order. Priority queue not maintaining any order. Similarly, priority blocking queue. This is also working based on the first in first out or priority of the elements. Priority blocking queue is not maintaining any order. Now, difference between priority queue and priority blocking queue is the methods of priority queue is not synchronized and thread safe. Methods of a priority blocking queue. I'm just giving some small notation. PBQ is thread safe, unsynchronized. This is the main difference between the priority queue and priority blocking queue. The difference between priority queue and linked list is this one. Working based on the first in first out or priority of the elements, priority queue. And linked list is working based on the first in first out. Maintaining the sequential order in case of linked list, it is having some order, but priority queue is not having any maintaining any order. These are the difference between all these subclasses of queue. Let's go to the next program. See, we have abstract queue, which is a subclass to queue interface. By using abstract queue also, we can create a queue object. How to create the queue object of abstract queue? We cannot create a object to abstract class of abstract queue. We can create object to the subclasses of this. Linked blocking queue is a subclass of abstract class. So I'm creating object to the linked blocking queue. And just adding the elements 10, 20, 30, 40, 50 to the queue. So after adding the elements, I'm just printing the elements. After printing the elements, if you want to get the first element, we can get the first element by calling the object.element. We have element method to get the first element of the object. And we have peek method also. By using peek method also, we can get the first element of the object. By calling poll method, we can get the object and we can remove the object. It will remove the object. We are using for each loop to iterate the each and every element and getting the each and every element. See, printing the each and every element here. So if you want to clear all the queue, like I have all the elements of 5 elements here. If you want to clear all the elements, if you want to make it empty, we have a clear method. By calling clear method, we can get the output as empty queue. That is the use of clear method. Now, abstract queue contains of 10, 20, 30, 40, 50. Head of the abstract queue is 10. We got the head by calling element method. So again, I am just getting all the elements by using for each loop. Now abstract queue is empty. By calling the clear method, I cleared the all elements. Now in this program, we have seen clear method. This is one more queue abstract class. We cannot create object to the abstract class, but we can create abstract class object by calling the constructor of subclass to the abstract class. Now let's go to the next program in the queues. Now here learning the collection APIs, we have to learn how to use these classes. When to use, how to use. Now this is array blocking queue. Now we have seen priority queue, creating queue object using linked list, priority blocking queue, abstract queue, array blocking queue. These many classes we have under the queue interface. Now what is the use of this array blocking queue? See, if you want to create a queue class by giving some boundary. So if you want to create the queue class by giving some number of elements should be added to the queue. We should not allow to add more elements to the queue. Like if you want to specify the boundary for the queue, only add 20 elements. If you create the queue by giving a constructor argument as 20 capacity, it will allow only 20 elements. If you try to add more elements, it will give error, runtime error. So if you have a requirement of creating a queue object, we should allow only 20 elements. But our queue should give functionality of first in, first out, or it should give functionality of based on priority. So we can go with the queue collection class. So which queue we have to use is array blocking queue. This blocking queue, it will give some, whenever we're creating the blocking queue, we can give the size of the capacity of the queue object. Here I gave size is 3. Only I can add only 3 elements. Now if we try to add the extra element here, we'll get the runtime error. Add of 15 I am trying to add. See, the capacity is only 3. We should add only the 3 elements. If we try to add more elements, it will give illegal state exception because the queue is already full. Control D for deleting this. So if you have a requirement of creating a queue which will give the functionality of first in, first out, or reading the elements based on the priority, then go with the array blocking queue. If you have some specific size. Now we have seen all other queues, priority queue, linked queue, linked list, priority blocking queue, all are not having any boundary. All are having dynamic size. So this is a queue which we use for the, if you have a requirement of using the fixed queue size. Array blocking queue. Here this is simple example. To remove the elements also we can remove directly. ABQ dot remove of first element, or if you just call remove, it will remove the first element. Now let's go to the next. All methods are same for all these queues, but we have to learn when to use the array blocking queue, when to use the priority queue. Those all we have to understand. Now let's go to the next program. Here concurrent linked queue. See, this queue is used for implementing the queue with the help of linked list concurrently. See, concurrent means thread safe. If you want queue with the thread safeness, which will provide the linked list functionality. So we can go with the concurrent linked queue. We can go with the concurrent linked queue. By using concurrent linked queue, we'll get the thread safeness and synchronized methods are there inside the concurrent linked queue. By using that, we'll get the thread safeness and it will provide the linked list functionality. So I just adding the elements to the concurrent linked queue. All the elements are adding in one order. It's having one order. Whenever we try to read the elements, it will give in one order. So we'll get the output of getting the elements from top to bottom. Here, I'm just getting the concurrent linked queue, printing the concurrent linked queue. We'll get the output of 1270 1009 475. Concurrent linked queue of integer. By using constructor of concurrent linked queue also, we can create the another queue. By using CLQ, I am creating CLQ1, only using the constructor. So I got the second queue, CLQ1. Now if you want to read the first element, we can call the peek method, or we can call element method also. By calling element method also, we can get the first element. By calling peek method also, we can get the first element. Whole method, it will get the first element and it will remove the first element. And again, we are calling the CLQ. On size of the CLQ, we are printing. And let's go and run this. Now my concurrent linked queue is this one. I just created concurrent linked queue by using the Q1. I created one again. So reading the first element is by calling the peek method, or we can call element method also. Whole method, it will get the element and it will remove the element. First element, it is removed. After removing that, we got the output as like this: 70, 1009, 475. Now it's giving the same functionality of linked list, but it will provide the thread safeness. If you have a requirement of using thread safeness and getting the linked list functionality of this queue, we can use this one. First in, first out. All classes, whatever I'm telling based on the when to use these classes. If somebody asks, if you have a requirement of creating a queue class object which provide linked list functionality and thread safeness, how to use, we have concurrent linked queue. That is the answer for that. Now, in program 6, I have main method. I just created object to the linked blocking queue. After creating object to the linked blocking queue, I just added the all elements 1, 2, 3, 4, 5 to the linked blocking queue by calling add method. So I'm just printing it. It is straightforward. We'll get output of 1, 2, 3, 4, 5. Now I have created a vector class. I'm just adding the same elements 1, 2, 3, 4, 5 to the vector. So whenever you want to create the linked blocking queue, you can give any collection type as an argument. Here if you see collection, the argument is a collection type. Collection type is this all classes: vector class, list class, array list, linked list, has set, everything will come as a collection type only. So we can add that collection type. I gave a vector type and I created linked blocking queue. This is a straightforward thing. This is, we got the output as same. But now here, when to use the linked blocking queue? You want to achieve the linked list functionality, and there is no like if you want to provide the some boundary, if you want to add only 5 elements to the linked blocking queue, we can add the 5 elements. This is optional. Like if you want to add only 5 elements, you can add based on the based on the constructor of linked blocking queue. If you provide the capacity, it will take only 5 elements: 1, 2, 3, 4, 5. If you try to add any other element, if I give 3, it will give error, because we added the capacity is only 3, but we added the 4, 5 elements also. So we'll get the output as empty. We got the output as queue already full. We got the error message. If you give here 5, we added only 5 elements, so it is allowing. We got the output like this. But the capacity is 4, but we try to add the 5 elements. We'll get the output as error. That is called linked blocking queue. But this linked blocking queue, the boundary is not mandatory. The boundary is optional. We can use the boundary or we cannot use the boundary. If you use the boundary, we have to add only that much elements. If we don't use the boundary, that is also fine. We can add the elements dynamically. That is the use of linked blocking queue. But if you use array blocking queue, here if you not give the boundary, it will give error, because the constructor of array blocking queue is will have argument of capacity. We have to give the mandatory capacity. Without giving the mandate of capacity, it will give compile time error. So what is different between array blocking queue and linked blocking queue? By using array blocking queue, we can have the queue size declared at the time of creation. Whatever size we declared, we have to add that many elements. We cannot add the more elements to the array blocking queue. That is called the queue is having a boundary. But if you go to the linked blocking queue, the queue is having the boundary or the queue is not having the boundary. That is, queue boundary is optional. We can give or we cannot give. Based on the, if you give the boundary, we have to add that many elements. If you are not giving the boundary, you can add any number of elements. That is the main difference between the array blocking queue and linked blocking queue. Now this is about the queues. Command Shift W to close all the queue related things. Now we can see the hash map interface. Just to disconnect and connect again.